All right, we have a can again. A can is the shape of a cylinder. Okay, if its radius is 3x inches, so that's from here to here, the center, you know, it's on the diagram, and the height is 5x to the fourth, we want the volume of this can in terms of pi. Before we do that, because remember that pi r squared h is the formula for volume, that means we're squaring something. I know you know how to square it, but there might be an easier way to do that. So let's take a look at this next piece of information. I would like you to answer these next two, true or false, in your workbook, and come back and we'll talk about them. Okay, so let's take a look. I'm going to do the left side, then I'm going to do the right side. And if it's equal, obviously it's true. Okay, so here we go. This is 6 times 3, or 18 squared. All right, and 18 squared is, I have no idea. Let's check. 8 times 8 is 64. Carry a 6. 8. 8 plus 6 is 14. We get 8. We get 1. We get 4. 324. Okay, so we know that side is 324. If this side of the equation is 324, we know we have a winner and it's true. Okay. 6 squared is 36 times 9. 9 times 6 is 54. Carry the 5. 27, 32, 324. So yes, that is true. True statement. That is a true statement. Ready for this one? This one's a little easier, a little less math. Okay. 6 plus 3. 6 plus 3 is 9. 9 squared. That is 81. I could do that in my head. 6 squared is 36 plus 9. 36 plus 9 is 45. That is not true. So that is a false statement. That is a false statement. 81 equals 45 is a false statement. Let's see what we just did. You ready? I'll show you. It's very cool. You probably missed it. All right. If you were looking, you should say, well, it looks like she used this time, used the same numbers, and it squared each one. Here she did the same thing with the plus. And I did. What I did was I did something called, I multiplied my exponents. I kept my base 6. I multiplied my exponents, and I just did it to both factors. And that's a true statement. I tried to do that here, but it did not work here, because here they were terms. So I can multiply my exponents, keep the base, multiply my exponents when I have factors. That is called the power to power rule. Let me show you an example that's on your next slide. Okay, here's how this works. Negative 3, x to the fifth, all raised to the second power. Power to power rule says we're allowed to do this. I can take each factor, and there's an exponent on every base, so that's negative 3 really to the first. But when I have numbers, I'm going to keep them in parentheses. I'm going to keep my base, negative 3, multiply my exponents. 1 times 2 is 2. Keep my base, multiply my exponents. 5 times 2 is 10. Okay, and now I have negative 3 squared, which is negative 3 times negative 3, which is 9x to the 10th. Okay, and that's it, you're done. I need you to be careful of doing this. Without the parentheses, this would be a negative 9, because the only thing being raised would be the 3. That is the wrong answer, because if I take negative 3 and I square it, we're going to get a positive 9. Now you might be saying, well, why did I do that? I mean, I could have just wrote this twice and multiplied it. You could have. But what happens if this is a 4 or a 5 or a 6? Do you want to write it that many times? I think not. So you'd want to do power to power. So the power to power rule works on factors only. Power to power, factors only. Now notice, reducing works on factors only also. Okay, a lot of rules work on factors only. But remember that your coefficient is a base, so you have to deal with that as well. Don't leave that out. Okay, so let's take a look at another problem as soon as we get this off the board. All right, so on that last slide, there was a rule in symbols and there was a rule in words as well. So make sure you notice that. If you're not sure what it means, ask your instructor. Let's take a look at revisiting the challenge question. We had that can, okay, or the cylinder, and we know the volume, we said, was V equals pi r squared h. Well, a can shape of it says find the volume in terms of pi. So we're not changing pi. Pi's staying pi. The radius is 3x. And the height is 5x to the fourth. So that's what we have. And now we're going to do this problem. Pi, I'm going to use the power to power rule. Okay, so there's a 1 there, there's a 1 there. So it's really, I know you can do this easier, but I'm going to do this anyway just for practice. Okay, times 5x to the fourth. So this is, ready? V equals pi 9x squared times 5x to the fourth. I don't really need the parentheses here, but I thought it just was getting ugly. I can multiply numbers together. V equals 45 pi x to the sixth. Because I keep the base, add the exponents. I did not have to put the pi here, but it actually usually is before this x to the sixth. So you could have said 45x to the 6 pi. It doesn't matter, okay? But here we go. And it's cubic, it doesn't, inches, because it says inches. Cubic inches. So that's the volume. And that's why we talked about the power to power rule, because I can use that right here. Okay, so that was the whole point of that challenge question. Okay, so I'm going to do a couple more questions with you. I mean a lot more questions with you. Okay, I'm going to start with this first one really quick. It's a to the fifth all to the second power. And then we're going to have to erase the board to get the rest up there. But okay, power to power. Keep the base, multiply the exponents. 5 times 2 is 10. Right, so instead of going a to the fifth times a to the fifth, we can just do that. A little more simpler. One more. I think we have room for x squared. X to the fourth, oh wait, sorry, fifth. Oh, I got to get new glasses. X to the fifth over y all cubed. Okay, here we go. Power to power. All right, I'm going to put a 1 there. Power to power says keep the base x. 5 times 3 is 15. Keep the base y. 1 times 3 is 3. Done. Another way to do this would be to write this 3 times and multiply it up, but I don't have to. That's a little easier. Power to power only works on factors. You might say these aren't factors. Think about it, they are. Division really is the same thing, because division, I could write this if I want as x to the fifth times 1 over y. That'd be the same thing. So they are factors. So multiplication or division, you're still factors, same thing. Okay? All right, we're going to do a couple more problems, and then we'll let you go on your own. All right, you ready? These are attached by multiplication, so we can use the power to power rule. X squared, y cubed, all to raise to the sixth power. Okay, so it's the quantity of x squared, y cubed, all to the sixth. Keep the base. 2 times 6 is 12. Keep the base. 3 times 6 is 8. Oh, come on, these are fun. Easy. Now we could do this instead. X squared, y cubed, x squared, y cubed, x squared, y cubed 6 times. Or we could just do that. It's a little easier. Okay, let's take a look at this. Problem, problem, problem. I know it's a problem. No, it's a problem because these are terms. I know you want to do this. I know you want to do x squared plus y squared, but you'd be wrong. You cannot do the power to power rule on this because they're terms. No power to power rule on terms. You want to learn how to do this? Okay, well, right now we're on lesson 2. Come back when we're on lesson 6, because that's when you'll learn how to do this. Okay, cannot do this right now. They're terms. Be careful. No power to power rule on terms. Ready for this? Here's my suggestion for you. Because we raise each factor, okay, and each base, we keep the base and multiply the exponents of each factor, I would make sure I know what the coefficient here is. The coefficient there is -1. So this is how I would do this problem. You can do it differently. I would put exponents wherever I don't see them. Okay? So here we go. So now, power to power. -1 raised to the 4th power. X, I don't need parentheses on my variables. X to the 4th power. Y to the 8th power. 2 times 4 is 8. 2 to the 3 times 2 is 6. Okay? Generally, I was putting parentheses around them, but there's no parentheses on there. If I want to, I can. It does not matter there, to be honest. Y to the 8th, kind of a special case. -1 to the 4th is just a 1 times x to the 4th, y to the 8th. I'm going to leave 2 to the 6th. You know why I'm going to leave it? It's a big number. So what did I do here? I did almost nothing. But I just made sure you understood this was 1. So now 1 times anything is the anything. This is x to the 4th, y to the 8 plus 8 is 16. And 2 to the 6th. I can leave that 2 to the 6th if I want. If I don't want to, I have to work it out. 2 times 2 times 2 times 2 times 2 times 2, you know? And it's 64, by the way. How did I know that quickly? Do you want to know how I knew that? I'll show you. Because 2 times 2 times 2 times 2 times 2 times, here's how I knew. I already knew 2 to the cubed was 8. Had I know that? Because I've been teaching for friggin' ever. Okay, so this is 8 and this is 8. We multiply, we get 64. So that's how I knew it was 64. Not because I'm really that smart, just because I'm really that old. Okay, so I'm going to do number 6 for you, and then I'm going to do a couple from the next slide, and then I promise you're on your own. Okay, power to power, we can do it because they're factors. Wherever I don't see an exponent, I'm going to put a 1 in there. Here we go. Actually, I don't need the 1 for that one because that one's not being raised, but who cares? Doesn't change it. Okay, so here we go. 3, the numbers I'm going to put in parentheses because if there was a negative there, it would matter. 1 times 2 is 2. X to the 5 times 2 is 10. Y to the 1 times 2 is 2. On the bottom, ready? 15 is not being raised. 15x, 3 times 3 is 9. Y to the 4 times 3 is 12. Now, I am going to deal with this, and I'll tell you why. We have numbers top and bottom here, so and letters, so I'm going to reduce. So 3 squared is 9, x to the 10th, y squared. 3 squared is 9, that's where I got that 9. 15x to the 9th, y to the 12th. Okay, here we go. We're going to reduce. Remember, when we reduce or divide, we reduce the numbers and we subtract the exponents of the common base, leaving your answer where the bigger one is. Was that a mouthful? Okay, so we look at 9 and 15. The biggest number that divides into those are 3. 3 goes into 9 3 times. 3 goes into 15 5 times. Look at your x's. There are more x's upstairs, so I cross this out. There's 1 more x, and there are more y's downstairs. You're not dividing, you're subtracting. There's 10 more y's downstairs. So the answer is, on the top, 3x times 1, or just 3x. On the bottom, 5 times 1, or just 5, times y to the 10th, or 5y to the 10th. I know I'm done because there's nothing left to reduce. That's it. Pretty cool problem. Do you see they're getting bigger? Isn't that cool? All right. We got a couple more to do together, and then I promise you're on your own. Okay, let's take a look at this. It's the same base, so we're going to keep the base, -10, add the exponents. Now, I have to tell you, you can have that answer, or you can have this answer. Do you know why? Okay, I'll tell you. Because either way, you're going to get a negative back. If a negative is raised to an odd power, you're going to get a negative. And here, the negative is not even being raised. You just bring it down. So either answer would be correct. If that came out to an even exponent, if that was -10 to the 12th, you'd have to leave the parentheses on it. Because if you have -10 to the 12th, that's going to come out positive. Whereas if you have, I should say, I'm sorry, I said that wrong. The quantity -10 to the 12th, that means the whole thing is being raised to the 12th. That will turn out to be a positive. -10 to the 12th will turn out to be a negative. So if this was an even number, those parentheses would be absolutely necessary. But when it's an odd, it doesn't matter if you have them or not. So be careful with that, because it will depend on what is accepted as an answer. Okay? All right, let's look at this one. Let me get this out of here before you think it's part of that problem. Okay, this is -10 to the 15th. Same thing. I can have on this -10 to the 15th, okay, because it's an odd power. Let's look at this. This looks like a problem almost like what we just did. The bases are not the same, so we cannot combine these. So we cannot keep the base, add the exponents, okay? We're not trying to combine them. We're trying to multiply them, and we're going to have to do order of operations. Okay, so this is 3 squared. 9 times 5 cubed, 125. And again, the reason for this is because the bases do not match. 5 times 9 is 45, carry to 4, 18 and 20, 22, carry to 2, 1,125. So that's it. That's all you got to do for the first 3 problems. And again, it doesn't matter which way you have this. Okay? If you're not sure whether you need the parentheses on or off, you probably should keep them on. Okay? Because it doesn't matter either way. We're going to try the next 3 as soon as we get these off the board. All right, here we go. I know these look almost the same, but watch what happens here. Here, the entire negative a is being raised to the 4th power. So it's -a times -a times -a times -a. That's going to be a positive a to the 4th. So it's a positive a to the 4th over a -a to the 4th. Well, nothing much is going on here, because what's happening is, and if it makes it easy, you might want to put a 1 here. You might be able to see this better, is that the a to the 4ths reduce out because they are the same number, okay? And then you have 1 over -1, which is clearly just -1. So that's it. That's how you do that problem. All right, let's take a look at this problem. Negative 3 squared. The only thing being squared is the 3. Here the 4 is being squared, here just the 2. Okay, here's the deal. I cannot reduce here like I have been trying to do all day here for this lesson because these are terms, so I'm going to have to actually do this. So this is negative 9 plus 16 over negative 4 minus 3. Don't reduce these guys. Don't reduce the 3 with the 9, the 4 with the 16 because they are terms. Cannot reduce terms. Okay, so we have negative 9 plus 16. So I owe you $9, but I have $16. Good for me. That makes me have 7. I owe you $4. I owe you $3. I owe you 7. So again, negative 1. Oh, you think this is negative 1? All right, let's see. Okay, power to power. This is 7. Really, this is just 7 to the 4th over 3 to the 4th. I don't want to multiply this out. The numbers are too big. Watch what I can do here. It's very clever. This is 7 squared. 7 squared over 1. Watch. On the top, keep the base. 7. Add the exponents. 4 plus 2 is 6. I can keep the parentheses. I don't have to keep the parentheses. It doesn't matter. Matter. Let's say that again. Matter. Doesn't matter. So this is 3 to the 4th times 1, which is 3 to the 4th. I can have the parentheses or not. And I am done there. Either one. Either one is done. And that's it. The answer is not negative 1. Okay, so those are a couple more examples. There are 4 examples on the next slide. You try those. Click back when you're ready. Please try to do them because then we can see what you're doing wrong. If you don't get it right and I do it over, just don't copy my answers. If you're not sure why yours are wrong, then ask the instructor. All right, here we go. All right, my suggestion, put that 1 in here. All right, just make it a little easier for yourself. And then whatever doesn't have an exponent, I'm going to put 1 there for it. So that's an exponent of 1. Because remember, we're going to do power to power because we have factors here. So it's negative 1 to the 4th power, x to the 3 times 4, or 12, y to the 1 times 4, or 4. But negative 1 to the 4th power is just 1. We don't need to write the 1 if we don't want to. That is our final answer. Hope you did good. Hope you did well. Whatever. Okay, let's take a look at this one. Again, we're going to do power to power because we have power to power here. Power raised to another power. Okay, I'm going to put 1s wherever I don't see exponents. Here I go. Keep the base 3. 1 times 3 is 3. Keep the base a. 2 times 3 is 6. Keep the base 5. 1 times 2 is 2. Keep the base a. 3 times 2 is 6. Now, here's the deal. I'm actually going to multiply this. I cannot do that same rule here, keep the base, add the exponents, because these bases don't match. So I'm going to actually have to do this. 3 cubed is 27. 5 squared is 25. And I believe 27 times 25 is 1,025, but I'm not positive. No, that can't be right. That's not right. 7 times 5 is 35, 3, 10, 13. 2 times 7 is 14, carry the 1, 5, 675. I was way off. Where was I going? So it's 675. A to the 12th, because I'm multiplying, so I have to keep the base. Here's where I add the exponents. Remember, don't multiply them because we're multiplying. Never do the exponents, what we're doing to the operation we're performing, because remember, we only multiply exponents when we do power to power. So I am done there. Awesome. Okay, ready for this last one? Last one on the board, not last one I have to cover. I know you have one more that you did. Okay, so let's take a look at this. I'm going to put now I know you can reduce here. There's always other ways to do the problem, but I'm going to stick to certain rules. If I see power to power, I'm going to do that first. I'm not going to reduce first, and there are reasons for that. So I'm going to go 3, keep the base, 1 times 4 is 4, a to the 5 times 4 is 20, b to the 3 times 4 is 12, that is 20, a to the 3 times 4 is 12, b to the 6 times 4 is 24. Okay, now you can either leave that as 3 to the 4th or do 3 to the 4th. 3 to the 4th is 81. That's absolutely up to you. Okay, now there are more a's upstairs. There are 8 more a's, so we get 81a to the 8th. The b's are going to be downstairs because there's more b's downstairs, bigger number, and 24 minus 12 is 12. So it's 81a to the 8th b over b to the 12th. And that takes care of that problem. So just go slow, reduce. It's kind of fun. All right, we're going to do the next one as soon as I get this off the board. Okay, remember we can't reduce here because we have terms, plus we have to do order of operations down here. So let's see what we got. Remember, the only thing being raised here is the 2. So it's negative comes down, 2 times 2 times 2 times 2, which is 16, plus 3 squared is 9. Parentheses first, if there's an operation inside, and there is. I owe you 4, but I have 3, so I owe you 1. I owe you 16, but I have 9, so I owe you, right, because I owe more than I have, and that's 7, all over 1, which is negative 7. Done? Oh, timeout. Nope, that's right. Didn't see that. Okay, so that's it. Negative 7 is the answer. Now, there are 2 problems on the next slide which tell you to substitute. Try those in your workbook, and then click the video to start over, and we'll go over those. All right, the whole point of this problem is to make sure you're careful about how you substitute and your use of parentheses and exponents. So let's take a look at this. Negative x squared plus, remember how we said we would do this, right? We use parentheses for the letter, and then the exponent's going outside. So x is negative 3, y is 4, okay? And then on the bottom, negative w squared minus x. W is 2, and x is negative 3. Okay, so here we go. I can't do negative negative because I got to do order of operations, which is exponents first. Negative 3 quantity squared is 9, so that is negative 9 plus 16. 4 times 4 is 16. Here I have negative 2 squared, so negative 4 plus 3. Negative 9 plus 16 is 7 over negative 1, which is, again, negative 7. So, again, it's just order of operations. Just be careful with where your exponents are. They're outside of parentheses, and make sure you're careful about your negatives in your order of operations. Okay? Let's see how messy this one could get. I'm going to make this parentheses really large, and it's w minus x plus y minus z. And w is 2. X is negative 3, y is 4, z is negative 5. Okay, here we go. This becomes 2 minus a minus 3. Put that little square outside, which is 2 plus 3 plus 4 plus 5, okay? Minus a minus becomes that plus. Minus a minus becomes that plus. 2 plus 3 is 5. 5 plus 4 is 9. 9 plus 5 is 14. Squared. So now I just take 14 and I square it, and that is 196. And I'm done. So there's substitution. Okay, the next problem is make sure you understand everything we've done so far. So try to do that problem, and then we'll come back and look at it. Okay, we want to explain what this means, and hopefully if we can explain what this means, then we can determine what the problem is with this. Okay, x to the 8th means x times x times x times x times x times x. Do I have enough? 1, 2, 3, 4, 5, 6, 7, 8. So that's x to the 8th. It means use x as a factor 8 times. Well, that's why x to the 5th plus x to the 3rd cannot be x to the 8th, because x to the 5th is that, plus x to the 3rd is that. That is not x to the 8th, because that would have to be a multiplication sign. This is clearly just x to the 5th plus, x to the 3rd. That cannot be simplified. We already talked about that before. So looking at the rule on the next page, okay, or next slide, if you will, we should be able to determine what to do. When you want to combine, you need like terms. So in our problem, on that slide, it says 8x to the 5th plus x to the 5th x to the fifth plus x to the fifth minus 3x to the fifth. Okay? And notice what you have to do here. These you can combine because they're like terms. Think of this as being a 1. Okay? I have 8x to the fifths plus 1x to the fifths. That's 9x to the fifths minus 3 of them. And that gives me 9 minus 3 is 6x to the fifth. So we need like terms. And then you recall this from a previous mod, that like terms means same base, same exponent. It has to match. And then you just combine the coefficients. Because again, and we've done this before, 8x to the fifth plus 1x to the fifth means you have 8x to the fifths. Remember your whole refrigerator door thing I gave an example of a long time ago? Is if I have these magnets on my refrigerator door, 7, 8 of them. I add one more, right? 1, 2, 3, 4, 5, 6, there's 8 of them. I add an x fifth, then I take 3 away. What do I have? I have 1, 2, 3, 4, 5, 6. 6 what? 6x to the fifths. That's what that means. So I need the same like term, which means the same base, same exponent, combine the coefficients, keep the like term. And that's how we combine. Okay? So that's another rule that we're just kind of reminding you of. Okay, here we go. X to the fourth times x to the 11th. Keep the base, add the exponents. Okay, keep the base, subtract the exponents. Put in your answer where the biggest one is. We're not dividing the exponents. Be careful. Okay? There's more x's upstairs. How many more? 90 of them. So this is x to the 90 over 1, which is just x to the 90 done. Watch this. This is a cool problem. X to the fourth times x to the 0. X to the fourth times x to the 0 says keep the base, add the exponents, because 4 plus 0 is 4. Take a look at this one. Well, this is something divided by itself. As long as it's not 0, we're good. So something divided by itself is always 1. Let's talk about these two a little bit. We just said that x to the fourth times x to the 0 equal x to the fourth. Well, let's think about this. What could you multiply x to the fourth by to get you back to x to the fourth? 1. So that is telling me that x to the 0 is 1. Let's take a look at this. If we use the rules of exponents, the rules of exponents says keep the base, subtract the exponents. What's 100? 100 minus 100. It is 0. So again, it's telling me x to the 0 is 1. So now we have a new rule that's on your next slide that says another exponent rule. It's the 0 exponent, and it says anything to the 0 power is 1. Okay? Anything to the 0 power is 1. So let's look at some examples. All right, here's the deal. We now know that anything to the 0 power, except for 0 to the 0 power, but anything to the 0 power is 1. So because we know that, and because we understand when you have an exponent, what it really affects, would you try these 1 through 5 problems that are on your next slide and in your workbook, and then please try them, and then click back on the video and see if you're right. Okay, let's take a look. Some of them may be a little tricky. All right, this is 5 times xy to the 0 power. So this whole thing is raised to the 0 power. This whole thing is 1. So that makes this answer 5. Okay, because the 5 is not being raised to the 0 power, only this is. That's a cool problem. Just make sure you understand what's being raised to the 0 power. Okay, here, this is not 5 raised to the 0 power. This is 25 raised to the 0 power. How do I know that? Because when this can't, if it was 2 times 5 to the 0 power, that's the way it would look. In algebra, I know that if we have 7x, we don't need a dot to mean multiplication. But if you have a number, you need dots. Because if you write 25, I'm not going to assume that's 2 times 5. I'm going to assume that's 25. So this is 25 to the 0 power. 25 to the 0 power is 1. Okay? Because anything to the 0 power is 1. 25 to the 0 power, 1. Okay, let's do this one. This one's different from this one. Yes, there's a negative, but the negative is not being raised because the only thing being raised is what the 0 would hit if it falls, and that would be the 25. So this is negative 1. Okay, so they all look almost the same, and look, so far we got different answers. Okay, let's look at this one. Make sure you understand what's being raised to the 0 power. Here, the whole thing is being raised to the 0 power, so that's 1. Here, the 3 is not being raised, but that y squared is. So that y squared to the 0 power, that's 1. So this is 1 minus 3, or negative 2. Just be very careful about what's being raised to that 0 power. Ready? You want to fix your answer for the last one? Here we go. All right. This is negative 1, because again, only the 7 is being raised to the 0 power. Here, this whole thing is raised to the 0 power, so that's 1, and our answer is 0. So those are the answers to that question. There's one more slide left, a couple of last problems left in your workbook. Try to answer them true or false. If false, supply the correct answer, just making sure you understand these rules. All right, let's take a look at this. X squared times x cubed. We're multiplying, we keep the base, we add the exponents, so that is true. Awesome, I have nothing really to do there. Let's take a look at this. This is power to power. I have to keep the base, I have to multiply the exponents. So that is false, because here I added the exponents. So this is false. But now I have to give you the correct answer. Keep the base. 2 times 3 is 6. 2 times 3 is 6. That is the correct answer, okay? Because I keep the base, multiply the exponents. Number 3, we just said anything to the 0 power is 1. This might look like it's correct, but the 5 is not being raised to the 0 power. So it's 5 times 1 is 5. The answer is 5. So this is false, and the correct answer is 5, okay? This one, well, I can't really give you the correct answer, though this one is not it. Okay, because we haven't learned how to do this yet, but I can tell you that I cannot do this because no power to power on terms. So this is false. Stay tuned for the right answer. I'll give it to you one day. Okay, so that's it on that one. No power to power on terms. It is a false statement. I'm not going to give you the right answer. On this one, I don't know, does this look good to you? Well, you did reduce this. 6 divided by 3 is 2, so that looks good. X is 6x squared. Is that x to the third? Well, I know it can't be because you divided the exponents, and you can't do the same operation that you did with the numbers, so that it tells you to do, the division. So it should be 2, but now remember what we do with the exponents. Keep the base, subtract. 6 minus 2 is 4, okay? Leaving your answer where the bigger one is, and the bigger one is on top, so everything stays on top. So this is false. And that's it. So that kind of just summarizes all the exponent rules. So that's it on more exponents. Now, are we done with all the exponent rules? Think about what we did. We did positive exponents. We did 0. We didn't do any fractions. We didn't do any decimals. Okay? And we didn't do any negatives. So let's take a look at what's coming.